Hello and welcome to my tutorial for designing an FPS in Unity. An FPS, or first-person shooter, is a 3D game where the perspective is from the player. It's first person. So it's a very intense 3D experience, but it's a very close to the action type of game. And in this game, we're going to learn a lot of things. We're going to be programming pretty much everything ourselves. And so we're going to design this from the ground up. And we'll learn a lot about 3D game design in this project. I'll talk about the structure of this project as our project creates. So let's create our project, and that's going to take Unity about a minute or two to do. So let's start by clicking on New Project. I am going to use the newest version of Unity, which is version 2022.3.16. So, and that's the long-term support version. So that's as of January 2024, this is the newest version of Unity. Now, the project that I want to do is I want to use the Scriptable Rendering Pipeline, also known as the SRP or URP. And this is a type of 3D project that uses the newer type of rendering. Now, by choosing this, this might immediately kind of seem like, okay, we're setting ourselves up for some headache. And we kind of are, but only with legacy things, older assets. This is the future of how Unity is going to handle rendering. So we will want to create our project with this, and this is an opportunity for us to learn how to make a project in URP. And we're going to learn some of the headaches that come with it. So let's give the project a name. I'm going to call this FPS_Advanced Game Design, and choose a location where you'll be able to find it. Now, if you're going to plan on putting this on a flash drive, you do not want to work your project off of a flash drive. So pick a location on the computer. You don't really need an SSD. It's not going to behave well off of a flash drive. So I'm going to choose my desktop, and I have a folder called Unity Projects, and it's going to make its own folder here. You can already see my old Asteroids project in there. And so it's going to go into this folder. I am not going to connect it to the Unity cloud because I don't really see the point for a little learning experiment project. We don't really need that. So now we're ready to hit Create Project, and it will sit for a little while. So while Unity cooks, let's take a look at how we're going to structure this project. I've broken down the general design of this into 4 chapters, and each chapter is going to have a couple 5 to 7-ish videos with that concept, with that chapter. So in this first chapter was all about movement and building levels. So we're going to, and in this video, we're going to script up a basic first-person controller, and we're going to be able to move around, look around, jump. It'll be boring right away because we don't have a level, but we'll be able to move. Then in the next video, we're going to actually look at how do we make a cool looking level to enjoy and to explore. We're going to start with outdoor levels first using the terrain tool, and then move into indoor levels. And that necessitates learning how to do level transitions. And then we're also going to work with interactable objects. So like pushing levers, opening doors. Then in the next chapter, we're going to take a look at giving the player some kind of weapons or attacks. So this is going to include having multiple weapons, tracking ammo, being able to do some kind of basic animation, spawning projectiles, looking at the difference between projectiles versus hit scan, but also importantly, learning how to remember data between levels. So remembering ammo or health. Chapter 3 is all about enemies, and we're going to take a look at AI and patrolling, other cool things there. And then chapter 4, we're going to take a look at setting up objectives. Like if you hit 3 switches, a door in the first level opens. And so remembering things across levels. Okay, it looks like Unity's ready. So we're inside of Unity, and we are in a empty template for a universal rendering pipeline project. Nothing too terribly crazy there. So before I get started, I do want to check a few settings to verify that everything is how it should be. And you should check these too, because the very first thing I want to take a look at is the setting for our compiler. So it's under Edit Preferences. Inside of Edit Preferences, we want to verify that our external script editor, so make sure you click on External Tools in this list. Our external script editor is Visual Studio. If it says Open by File Extension, you'll want to either select Visual Studio or browse to where it is installed. And if it's not installed, you should install it. By selecting this, it lets Unity communicate to Visual Studio. So we will have IntelliSense, we'll have the keywording, we'll have the error checking. It's actually almost impossible to code a project without having this hooked up correctly. Then the other thing is I just want to take a look to see if the universal render pipeline settings are correct. And that's a project setting. So if we go to project settings, under the option for graphics, you should see that it says URP right here in this scriptable render graphics pipeline. If you ever wanted to switch it back to what's called the built-in renderer, all you have to do is choose none here, and then it will go back to old school Unity renderer. Now, the URP is considered to be the newer and kind of the preferred way down the road. So I really want us to get some experience using it and potentially see the headaches that could arise from using it. Now, if it does ever, like if you find an asset pack that you really love or shaders or graphics that aren't compatible with this, then it is very easy to switch it back by selecting none. But we're not going to pick none. We're going to leave it on URP high fidelity. If you have trouble seeing which ones these are, you can always adjust this. See that I have high fidelity selected. All right, so we've got our project. We have a camera staring at pretty much nothing. So let's start by putting some ground down, because we want to be able to make a player controller. We want to program our own first-person controller from scratch, so we need something to walk on. And since we're going to be designing an outdoor level first, what we're going to want is terrain. And that's under Game Object, 3D Object, Terrain. That inserts this giant checkerboard, not to play like super huge checkers or chess, but this is what we will sculpt into land for us to move around on. So some maintenance. I don't really like having it centered at 0, 0. I tend to prefer kind of centering it in the middle of everything. So I do need to take a look to see how big it is. So under the terrain options, I click on this 5th option, which is terrain settings. And I can see that it's 1,000 units. Now, 1,000 units is pretty big, and mine, maybe I don't want it that big. Maybe I'm just going to bump it down to like 500. That's still going to be plenty big. And so you can hardly even notice that I changed that. You would notice it if I dropped it down to like 200, though. So if I bring this to 200, we can kind of see it's starting to get pretty small. So I'm gonna set it to 500. So that tells me that if I do want the center to be 0, 0, I need my X to be negative 250 and my Z to be negative 250. Remember that up is Y, and so forward is Z, left and right is considered to be X. All right, so we've got a giant plane here. And the camera is still hanging out at basically the origin. So let's add a player, or well, let's build a player. So typically, players are built out of either of these 3D shapes. It will eventually get replaced, but sometimes out of a capsule and sometimes out of a cylinder. I'm going to go with a capsule. Ultimately, it's really not going to matter because we're going to replace it with a player controller. So I'm going to rename this from capsule to player. And its XYZ got a little bit mangled, so I'm going to reset the transform by right-clicking it. And then the Y, I'm going to pull it up by 0.5. Might need to be more than 0.5. Yeah, we'll just pull it up even higher. We'll let gravity take the wheel here. So this will be my player. Now, I actually will not need the capsule collider, so I'm just going to replace that by going to remove component. And I'm going to add on a component. I gotta remember what it's under. It is a player controller. Yeah, character controller. So it's under physics character controller. And a character controller is essentially a special collider, because it will behave as a collider. That also has some control over how it like walks up things. For example, what's the steepest slope it's allowed to walk up? What's the biggest step size it can walk up? Many people tend to increase the radius to 0.6 to better match a capsule. Just a scale of units here. In general, 1 Unity unit is considered a meter. So some food for thought that a unit that is 2 meters tall would be considered to, or I'm sorry, an object that's 2 units tall would be about 2 meters or approximately 6 feet. So that's going to be kind of the scale that we go with. Okay, we don't need to really change anything else there. One thing that I will do to make things a little bit easier is I am going to take main camera and I'm going to make it a child of player by dragging and dropping it, targeting player. So you can see that it's now childed under player. And I'm going to reset its transform. And so you can tell that the camera is now being relative. It's at 0, 0, 0, but you can tell that 0, 0, 0 is relative to the player. You can also tell because it's set to local. So maybe raise the camera up a little bit so it's kind of the head of the player. So 1.2. And again, we can change this scale if our player feels too small. We can play around with this a little bit later. All right. So now what we need to do is actually start scripting this. So, I do want to clean up my terrain. Let's rename this. So I'm going to rename my terrain to, we'll call it level 1. And I'm going to make a folder for it. So I'm going to create a folder called terrain. Just so that I don't like to leave things in the root of my assets. I like to have folders for them, which is what I'm about to do for the scripts. So I'm going to create a folder called scripts. And then inside of that folder, I'm going to create another subfolder called player. Because eventually we are going to have like enemy scripts, world scripts. We're going to have a lot of scripts going around. So just have a player script here. And let's create our script. So I'm going to create a new C# script. And I'm going to call this FPS underscore controller. That's 2 L's. So I've got my script here, and it's largely empty. but we're going to program this up so that we can move around, and then our first video will be a success. So double click your script and Visual Studio should open up. So here's Visual Studio. Now you'll know that it's happy. Let's not update. So I might be missing some components. So you can tell something's not going to work if it's not auto-detecting mono behavior. You can see that there's a lot of keywords here, but mono behavior is still black, kind of like a variable. So let's see what I need to install. It's probably going to recommend the Unity package. Yeah. So game development with Unity. Yes, that's fine. All right, well, I can let that go while we program. So, oh no, it closed Visual Studio. Well, that's disappointing. So, while it does its thing, let's see if we can do anything here. Oh, we can poke around in tutorials. I'm gonna delete that. README. And we're gonna delete README. Let's just hope we don't break anything. Okay, so Visual Studio is updated and we are good to go. So still loading. So let's check to make sure. Well, I guess I'll have to fix that in between our videos. So we're just going to do our best, and we're going to do our best. All right, so let's start off with the requirements. So because this is a player controller, I want to use this keyword up here called require components. Then in parentheses, type of capital C character, capital C controller. And what that does is in Unity, this script is not allowed to be attached to an object until it has the component character controller, which we just added. So let's set up some of our instance variables. So I'm going to create some categories for the public variables. So I've got this category called movement settings. And we can even add a tooltip if we want. All right, so the variables that I think we will need a public float speed. This is our movement speed. Perhaps I should rename this to movement speed to give an idea of what that's for. So that movement speed is how fast we're going to go. And effectively, in case you are curious, this will work out to be 5 meters per second, so like 5 Unity spaces. We will want a run modifier, so that if I'm holding down shift, I get a speed boost and a jump height. So that should be approximately 2 units high of jumping. So it'll be close to that. Now a mouse sensitivity for a mouse look. This is relatively subjective. I just picked 4 because 4. That's what I've tested it to work best with. Then we want a option for people who like to inverse their mouse look. And so that'll be a checkbox if you want to. And if we were to make a settings menu, we would allow the user to adjust the sensitivity or the mouse look. So then the next header would be our world settings. This is not going to be a whole lot. This is basically just gravity. So negative 9.81, that's meters per second squared, I believe, and which is normal Earth gravity. I'll just call this required objects. So the tooltip here, we'll do a so this effectively is the player's head. So this is public game object, player head. So this is going to be the camera that we will move around when we're using mouse look. So here's our first setting of variables. These are our public variables. Now we're going to go through and then work through our private variables. So the private variables, these are variables that we don't need to edit inside of Unity. These are for our own computations. So this is the X rotation for up and down looking. This is to remember how much tilt up or down the camera has. A vertical speed variable, and this is going to be useful because we're not going to use rigid body. We're going to essentially simulate physics ourselves. So we need to remember how fast we're falling. It gets a little weird if you, and actually just almost not even possible, to use rigid body with player movement. You kind of can, but you shouldn't. Like adding forces. Most character controllers do not use that. A variable to track if we are jumping or not. Could be useful to know. And a variable to remember the character controller. Now, if your compiler was set up correctly, this character controller variable should have keyworded to like a light blue if you're on light theme. But since mine did not, it doesn't really recognize that variable. However, if I do go back into Unity, it compiles the script and it already found some errors. So if you're having some issues, Unity still error checks. So like line 28, I've got an issue. So 28. Oh, see, I said private float is jumping. This should be a Boolean. Okay, so when the player starts up, we will want to find and attach the character controller. So lowercase c character controller is going to be set equal to get components. angle bracket, character, capital C, character controller. So the variable character controller, which is the lowercase c one, we're attaching it to the object type. So this is the capital C character controller. And then we want to hide the cursor. And you can get out of this by hitting escape. So cursor dot lock state equals cursor lock mode dot capital L locked. And again, a lot of this will autocomplete if your compiler is set up right. Unfortunately, mine's not, so we don't know till it works until Unity compiles it and checks. And so we could jump over, if you're doing this, you can jump over, you can see that Unity recompiles it, and I just have warnings that variables are not being used. And that's not a big deal. Okay, so this is where we're going to actually get into building the movement. And really, it's not a lot of code to get movement to work. So we're going to handle this inside of update, as opposed to fixed update, which is what you're supposed to handle physics things with. If you ran this in fixed update, players would feel it would be kind of not snappy. Like it'll feel like there's a delay to your inputs because fixed update runs at a fixed time interval, hence the name. Update runs every frame. So if you stop moving, but the next call to update your movement's not until like a few milliseconds later, you'll feel that there's a slight lag in how your controls are working. So we're going to handle this in update. So here's our section for movement-related things. So we want to grab a few things such as inputs. So let's get inputs. First up, let's get the horizontal input. Gotta watch out for that autocomplete one. So you hit escape to not autocomplete. So get access horizontal, capital H horizontal. Spelling does matter, and it will not autocorrect an incorrect spelled thing. So these keys are essentially H input is A and D, or left and right. This is W or S, or up and down. So the way that this works is it's going to be +1 for right, -1 for left. That's why they're floats. So, and actually it's a get access, so a joystick works just as well as the keyboard. And then let's see if get the key for running. Now, I'm not very happy that this is considered to be Fire 3. So input dot get button. Fire 3 is left shift by default. So we could go and rebind that or give it a better name. So let's go do that because we will have to make a few trips to the input editor anyway. So let's go and instead of it being a fire attack, we want something better. So over in Unity, to create new inputs, that is a project setting. And that is under Input Manager. And then we expand out the axes. And we can see that there's quite a lot, but the only ones that we really care about are kind of these first ones. And being duplicated, so that you see how there's two horizontals. By having two horizontals, it actually allows for two different possible settings. So this one is using keys, like you see it's using left, right, A, D. This one's using the joystick axis. But it has different settings for like the dead zone and the gravity of movement. So this allows multiple sources to be pulled to the horizontal controls. And they kind of like or together, I think. But the one that I'm most concerned about is Fire 3. So you can see that the positive button here is left shift. So, well, why don't I just make a new axis and just call it run? So I could increase this number of axes by 1. So instead of 30, I now have 31. Push enter, and it will update. Now, it is kind of silly in how it does this. It actually takes the last axis and decides to just clone it. So you can see that I have two debug horizontals and they're actually identical. So what we want is I actually want to copy the settings out of Fire 3 and put those settings into this, and I'm going to rename this to run. So, well, that's the joystick button. We want the top one. So this is left shift. So I'm going to just take that out of Fire 3 completely. So the positive button is left shift. Gravity 100, dead zone 0.001, so I'm sorry, 1000 and 1000, which is what it's already set here. Key or mouse button. So switch that to key. Axis, X, and then get motion from all joysticks is fine. So now we have run as a separate command. Fire 3, we can make that like, I don't know, Q. So now alt fire, maybe? Because Fire 2 is probably going to be aim down sights. So Fire 3 is Q. Maybe throw grenade or something. So it's Q now. But we have run as a button that we can read now. So if we go back to here, instead of Fire 3, we can say run, because it's a valid button now. So I'm just making a note here that we added a new axis for run. Okay, so now we're reading input from the user. We've got a horizontal, left, right, vertical, up, forward, back, and run. So we want to start by building a movement vector out of this. So that is a vector 3, so an X, Y, Z set of commands. That's what a vector 3 is. So forward movement. Oh, this is our name for it. Forward movement equals. Now we want to get the forward vector from the player. So if we say transform.forward, that is the way the player is facing. So since we're doing this every frame, if we turn, that vector is going to be a different value every time. And then we're going to multiply that by the input. The idea is that if you're pushing forward, so W or up, you will have a positive 1 here. So positive 1 times the forward vector means you will go forward. If you push back, this will be negative 1. And so you take the forward vector and multiply it by negative 1, and it becomes the reverse. And we'll do the same for left and right. So we're just taking the right vector, what is considered to be right. So if the player stuck their right hand out, just kind of T-posing, that would be your right vector, and multiplying that by H input. So now we're going to build our movement vector, our kind of combined movement vector. And that will be equal to, and I called this movement speed. So movement speed times the addition of the forward movement plus the right movement. So if you have two vectors and you add them together, you get a combined vector. Now, I suppose I could have an interim step here to eliminate moving forward and diagonal at the same time, giving you kind of a speed boost. But I don't want to overcomplicate this. If you push forward and right at the same time, technically you're going to move faster. And then we'll use a ternary if here. So the idea is that if running is true, then we will multiply by the run modifier, which is 1.5. Otherwise, we will just use 1.0 and basically not affect it. If you are concerned about moving too fast, we can normalize the vector. So this is actually a performance cost, so that there is something to be said for not doing this. So let's take our two vectors, forward movement plus right movement. If combined move dot magnitude is greater than 1, then combined move equal, thought I completed that, combined move dot normalized. So effectively, I mean, if you want to MS Paint this out, what happens is if I'm pushing this way on the controls and that's a magnitude of 1, and I'm pushing this way on the controls and that's a magnitude of 1, the resulting vector, if you add those two together, is a vector of 45 degrees, but with a magnitude of 1.14. You know, 1 squared plus 1 squared. You do Pythagorean theorem on this. So this normalization command will scale this vector back down to 1. But we only want to do it if it's greater than 1, because if you normalize it all the time, it prevents you from having small movements. Because, like, let's say you just kind of tap the key, and you're only tapping the key, just like you're tapping the joystick like 0.3. Then if you normalized that, it would force it all the way up to being a scale factor of 1. Then you couldn't just slightly move, or like kind of like walk. So we'll just use combined move there. Okay, so we could test this. We don't have jumping yet, so let's right after it enact the move. So character controller dot move movement times time dot delta time. Time dot delta time is the time in between each frame. So that makes a lot of sense to be done in update. And so it will kind of scale our movement to how fast the game is playing, so that if you're running at 144 frames per second, you don't get an advantage over somebody who's running at 30 frames per second. That kind of normalizes the game based on frame rates. Now, we don't have jumping yet, and we don't have mouse look, but we should be able to move left, right, forward, back. So I'm going to hit save on this, and we're going to test this code. Oops. So I got a few errors. So I'll have to go fix those. have an equal sign here I don't need. There we go. So we haven't implemented gravity yet, so keep that in mind. And I haven't put the script on the player, so nothing's going to happen yet. So we need to take the script that we just made and drag and drop it onto the player. And you can see that we can move. And this might be a good stopping point for us because we still have a little bit of code to do to get the mouse look working. So we still need to do gravity, we still need to do mouse look, but we have movement. You can tell that we're floating, but we can move. So we're going to stop here. In the next video, we're going to get jumping working, gravity working, and then mouse look. And then maybe put like a box or two so that we can practice hopping around and see how high the player jumps. So make sure you save your work. Here is our code for that last part, and I'll upload the code in a link to the video so you can kind of see the state of the code right now. And I will see you in the next video. Thank you for watching, and I hope you're excited to make a really cool 3D game.